You ever look up at the night sky and think, how small am I really? What if I told you that every human ever born, every city, every mountain, every ocean, is nothing but a speck in a universe so vast, it defies imagination? In the next few minutes, I want to drag your mind from that speck, out past galaxies, clusters, voids, to the very edge of the observable, and then whisper the terrifying possibility that the universe might go well beyond. Buckle in. We begin close to home. Earth. A blue ball, 12,542 kilometers across, spinning with us on it, circling a pretty average star. But even that star is insignificant next to the Sun. The Sun's diameter is about 1.39 million kilometers, almost 109 times Earth's diameter. Now imagine that scale is us zooming outward, Earth to Sun to all the planets. The orbit of Neptune alone is about 4.5 billion kilometers away from the Sun. Light takes around 4 hours to travel across that distance. Already, we're leaving human scales behind. But let's kick it up. Traveling outward, we reach our stellar neighborhood, the Milky Way galaxy. It's a spiral arm of stars, dust, gas, with a diameter, depending on measurement, of roughly 100,000 light-years. That's a path light would take 100,000 years to cross. Inside it, billions of stars. The Milky Way is part of a small cluster called the Local Group, which includes Andromeda and dozens of smaller galaxies. The Local Group itself spans over 10 million light-years. Now, that's still just our neighborhood, in a cosmic sense. Push further, and you hit the Laniakea supercluster, which our galaxy sits in. Laniakea spans about 500 million light-years. It's like a spiderweb of galaxies bound subtly by gravity, embedded in a fabric that itself is stretching. But even Laniakea is just a drop in the cosmic ocean, because the universe itself is expanding, and it's doing so faster than you might expect. What we can observe from Earth is limited. That region is called the observable universe. According to astronomy references, that observable bubble is approximately 93 billion light-years in diameter. That means if you draw a sphere centered on Earth with a radius of about 46 to 47 billion light-years, everything inside that is, theoretically, possibly observable. That's because space has stretched while light traveled. A galaxy whose light began its journey 13.8 billion years ago is now much farther due to expansion. Sources like Britannica and NASA agree on this. That 93 billion light-year diameter is the horizon of what we can see. Anything beyond has light that hasn't had time, given cosmic expansion, to reach us yet. So, 93 billion light-years across. Each light-year is not 9.46 trillion kilometers. Do the math. That's not 8.8 x 1026 meters across. It's a number so large you can barely name it. But here's an emotional twist. That's just observable. The real universe, what lies beyond, is likely far, far larger. Many cosmologists argue the universe may be infinite. Others place lower bounds, if finite, in the trillions of light-years. The truth is, we don't know. Forbes, astrophysics reviews, and cosmic inflation theories wrestle with this. Let's rewind and slow down for a moment. Why does this matter? Because scale forces perspective. You might hear there are 0.2 trillion galaxies in the observable universe. That means stars outnumber all the grains of sand on Earth, easily. The total mass-energy budget of the universe is 5% ordinary matter, what we see, 27% dark matter, and 68% dark energy, as per standard cosmological data. That means the stuff we know is barely a fraction of the total. Every 30 to 45 seconds, let me drop another twist. Here's one. The geometry of the universe, whether it's flat, open, or closed, determines whether the universe is infinite or wraps back on itself. Current measurements, Planck data, etc., indicate space is very nearly flat, implying the universe may well extend infinitely. But since every measurement has error bounds, there's wiggle room for a gigantic but finite cosmic structure whose circumference exceeds what we can ever observe. Back to scale. Think of the largest known structures inside our observable universe. The Hercules Corona Borealis Great Wall is a candidate structure spanning roughly 10 billion light-years in length. Insane. This pushes boundaries of what cosmology predicts about homogeneity. More recently, astronomers discovered a giant arc, which spans 3.3 billion light-years across galaxies and gas, challenging assumptions about large-scale uniformity. There's also the Big Ring, discovered in 2024, a ring-like structure, 1.3 billion light-years in diameter. These cosmic giants remind us that even inside only what we can see, scale breaks our sanity. Now let's shift energy. If you traveled at the speed of light, it would take 46 billion years just to go from center to edge of our observable bubble, ignoring acceleration, etc. But light itself doesn't go in the conventional sense. Space expands while it travels. So the distance to the galaxy whose light is just reaching us is far greater now, because of expansion. That's how 13.8 billion years of look-back ends up mapping to 46 billion light-years of distance. Crazy, right? Halfway through now. If you're enjoying this, hit that subscribe button or drop in the comments. What cosmic scale blew your mind the most so far? Let me know below. Zooming deeper. Beyond the observable, the universe may contain infinite regions, countless galaxies we'll never see, and perhaps entirely different physics. Some inflationary models suggest that the universe is a multiverse, patches with varied constants, physics, or that ours is just one bubble in a frothy sea of universes. But right now, our data only reaches the observable. We must infer what's beyond. Let me pull you back in with a visual. Picture a person on a beach holding a grain of sand. That's all humanity on Earth. Then picture the entire Earth as a grain in the Milky Way. The Milky Way as a grain inside Laniakea, Laniakea as a grain inside the observable universe, and the observable universe, a grain inside the ultimate unknown beyond. That metaphor drives an emotional punch, that we exist in a place so small, yet capable of realizing its own smallness. As our gaze pulls outward, another twist. Cosmic expansion is accelerating, driven by dark energy. Observations hint at something called the Hubble tension, where the rate of expansion measured locally, via Cepheids, supernovae, differs from the early universe predictions, via cosmic microwave background. The James Webb Space Telescope's data even confirmed the universe is expanding, 8% faster than expected by some models, deepening a mystery scientists are racing to resolve. Reported via Reuters and astrophysics journals. Every measurement might shift our understanding of how big is big. Let's roll this to a crescendo. Suppose the universe is infinite. That means every possible configuration, every permutation of matter, energy, life, occurs somewhere, maybe infinitely many times. That means duplicates of Earth, duplicates of you, duplicates of this video, infinitely many copies. Alternatively, suppose the universe is finite but unimaginably large, say 1,000 times the size of the observable, but closed. You might travel in some direction and eventually return, in cosmic time, to your start point, though you'd be billions of years older. That possibility is mind-bending. Now, the payoff. Here's the reveal. The true scale of the universe isn't just huge, it's a mirror for humility and wonder. In the span of cosmic history, human existence is but a flicker. The universe doesn't owe us meaning, but we are the universe noticing itself. And that to me is deeply emotional. As we wrap, remember, your perspective changes when you see how small your world is. But that doesn't weaken your significance. If anything, it highlights the fragility and beauty of consciousness in a cosmos that stretches beyond reckoning. If your mind's still racing and you're wondering what else might be hiding in the cosmic shadows, check out our video, What If Humans Weren't the First Civilization on Earth? It's a mind-bending theory that challenges everything we think we know about human history. Or dive even deeper with the Silurian hypothesis and the terrifying reason we haven't found aliens yet. A video that might just change how you see the Fermi paradox forever. Thanks for watching The Galaxy Explained, where we make the universe feel just a little more personal. I'll see you in the next one.